Welcome to the Chapter 9 review. This is Mr. Ensler. I'm going to be leading you through this. And Chapter 9 was all about transformations. Taking a geometric figure and somehow changing it, either just moving it or reflecting it or rotating it or doing something like that. So we'll start here at the beginning. The first page is all about translations, where you just move a shape up or down, left or right, or a combination of those, but you're not flipping it or rotating or changing its size at all. And so the first thing to notice is that you see this kind of notation where it says x, y, arrow, x plus 4, y plus 2. Now, what you want to remember is that x controls where something is from left to right, and y controls its location in terms of its height. So, if you're talking about the x from left to right, then as you go to the right, that is positive x. As you go to the left, that is negative x. And kind of the same thing with y. As you go up with y, that's positive. As you go down, that's negative. So, what you can do when you look at number 1, where it says xy, x plus 4, y plus 2, that means you're going to take the original shape and you're going to move it. And the x plus 4 means you're going to move it 4 to the right. And the y plus 2 means you're going to move it 2 up. Now, as you can see here, I have actually pre-graphed all of the triangles because it says in the directions the vertices of triangle MNO are at these places. So you can do the same. You can graph all 4 of those in advance. We want to do a really good job of graphing our original figures and labeling them with their correct letters, M and O in this case. Remember the vocabulary that we've learned, that the original figure, we call that the pre-image. And the changed figure, the one that has been changed somehow, we call that the image. And the original figure we draw with solid lines. The image, the changed figure, we draw with dashed or dotted lines. And when we label them, let's say this original figure was A, B, C for the vertices. The image would be A prime, B prime, and C prime. So they're very clearly distinguishable. You have to do that. That is part of what we've learned. Okay, so that's all a lot of setup. Back to number 1 here. What we're going to do is we're going to take each one of these vertices and move them over to the right 4 and up 2. So over 1, 2, 3, 4, and up 2. The new M will be right here. And we'll label that M prime. We'll do the same thing with all of them. O over 1, 2, 3, 4. And yep, sometimes you have to go off the graph a little. That's okay. And that is, when you go up 2, that'll be right here. And N, moving over 1, 2, 3, 4, and up 2. Oh, look at that. Just by coincidence, N is actually going to be in the same place. N prime will be in the same place that O used to be in. And then we'll connect those with dashed or dotted lines. And there we go, you're done. Now, the directions here did not say that you had to name the coordinates of the image of the new shape, but if you look at the answer key in the back, you notice that they are all listed like that. So it's not a bad idea to get in the habit of naming where they are. For instance, M prime is at 2, 1, 2, 3, 4, 5, 6, 2, 6. And N prime is at 3, 3, and O prime is at 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 7, 5. And that way it's really easy to check your answers with the answer key. Alright, here in number 2, what we're doing each time here is we're going to be moving it left 5, because negative for x is to the left, and down 6. Left 5 and down 6. So you're just going to count that many spaces for all of these. Starting with M, we go left 1, 2, 3, 4, 5, and we're off 1. 1, 2, 3, 4, 5, 6. So that will be down here. And that's going to be the new M. Where is that point? If we count from the origin, it's 1, 2, 3, 4, 5, 6, 7, negative 7, negative 2. Alright, O, counting left, 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5, 6. Here is the new O prime. And where is that point? What's the location of the point? It's at negative 2, negative 3. So this one you can see is really moving. Alright, and lastly N, negative 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5, 6. It's down here. That is the new N. And the location of that point is negative 1, 2, 3, 4, 5, 6. Negative 1, 2, 3, 4, 5. So negative 6, negative 5. And we'll make our dotted or dashed lines. And what you notice about translations is that the shape and the angles are the same. The shape and the angles are the same. We call that an isometry. It has just moved. In number 3, we are moving to the left 3 and up 1. So left 3 and up 1, this would be the new M. Left 3 and up 1, this would be the new O. And left 3 and up 1, this would be the new N. Again, that's all you have to do at a minimum with these directions, but it is helpful to list the new coordinates so that you know if you're getting these right or wrong. So, for instance, M here, M prime, starting at the origin is negative 1, 2, 3, 4, 5, and positive 1, 2, 3, 4, 5. So negative 5, positive 5. N is negative 4, positive 2. And O prime looks like it's right on the y-axis, so it's 0, 4. Number 4. Now notice here there's no number next to the x. That means the x is not moving left or right. It's just going to stay where it is. It's like x plus 0. But this one is going to shift down 5. So this will actually be kind of easier. We just count straight down 5 from each point. So M, we go down 1, 2, 3, 4, 5. We end up right here. That point is negative 2, negative 1. O, if we count down O, 5 will be right here. So O prime is there at 3, negative 2. And N, 1, 2, 3, 4, 5. There's the new N. And we would be at negative 1, negative 4. Remember, when you name the coordinates, you always want to start at the origin. So to get to n prime from the origin, we have to go left 1 and down 4. So that's why its points are negative 1, negative 4. And then we'll connect that with a dotted or dashed line. And you see we have our new shape, just moved down 5. Alright, the next ones you can see have already been done for you. The directions say R prime, S prime, T prime is the image of triangle RST after a translation. Write a rule for the translation. So now you have to be the one to put down parentheses x, comma, y, arrow, and then we're going to do something with the x and something with the y. So when I see a problem like this, I automatically put down kind of the shell or the notation of what I'm going to need to do. And so now you want to do the same thing where you count, but you'll want to pick one pair of points. So I'll just pick point R and R prime since they go together. And you want to count starting with the pre-image and then the image. So always make sure you start with the original. In this case, the original is the solid lined one. And so for x, looks like it went to the left 1, 2, 3, 4, 5, and then it went down 2. So for x, that's -5, and for y, that's -2. So x minus 5, y minus 2. And that's your answer. That's all you have to put down. What happened in number 6? Well, before I even look at it, I'm going to go ahead and put down my notation here. Sometimes people forget to put down the parentheses x comma y, but you have to have that. You're saying take each coordinate x, y and do this with them. If you don't have that x, y there, your notation is not complete. Okay, so let's pick a point in each of these. I'll pick point S, how about? So there's S prime and there's S. Oh, and look at this. We have to look closely with this one because the grid lines are going by 2's. You can see this is a 2 and this is a 4, and we're right in the middle of some of these grid lines. So we'll do the same thing. We'll count how far left or right and how far up or down. We'll just have to be a little bit careful about that. So we're starting with this S right here. This is the solid lined one, and we're going over to the right. So the question is, how far over to the right is that? Well, each grid line is 2. So from here to here, that's 1. And then from here to here, that's 2. So that's 3 total to there. And then 2 more, that's 5. So this is going to be x plus 5. It's kind of like it went 2.5 grid lines. And so you have to double that to 5. And it went up a half and a half. So 1 full grid line, which is 2. So x, or y, plus 2. So this one's positive because it went to the right and positive, up. All right. Lesson 9.2 is all about matrices. Matrices are very useful in the real world. They're going to help us perform these transformations that we learned, but they're also useful in computer programming, in statistics. Anytime you want to organize information into rows and columns, you use a matrix. That's what a matrix is. So we have some matrix operations here. The first thing to know about a matrix is how to call out the size of the matrix. And you always call a matrix by the number of rows it has compared with the number of columns. All right, and I know you all know the words row and column, but we have to be very particular about how we call those out. So for instance, let's say I have a matrix and it has numbers here, 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 and here, 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 and here, here, and here. All right, so you can see that there are 12 total numbers in there. You can see one of the numbers is going to be 3 and the other is going to be 4, but which is which? Well, rows is each line going across from left to right. So in this case, we have 4 rows, and columns stand vertically up and down. We have 3 columns, so this would be a 4 by 3 matrix. All right. In order to add matrices, the rows and columns configuration has to be exactly the same. It doesn't mean that these two numbers, rows and columns, have to be the same, but the total configuration has to be the same. So look at number 7. This is a 1 by 2 matrix because there's simply 1 row but 2 columns. And you can see the other one is also 1 by 2. So they can be added. In order to add or subtract, they have to be exactly the same. And so when you add these, this is also going to equal a 1 by 2. And adding is one of the easier types of things you can do with a matrix. All you do is add the numbers that are in corresponding positions. So we're going to start off by adding 2 plus 6. And 2 plus 6 is 8. Then we'll take the other numbers, 4 plus 3, and 4 plus 3 is 7. And that's our answer, just the matrix 8, 7. Sometimes people then add the 8 and the 7 together and they get 15. No, don't do that. Remember, this is supposed to be a 1 by 2. All right, so we'll just keep it in that same configuration. Number 8, same kind of thing except we're subtracting. You can see that this is a 2 by 2, 2 rows, 2 columns, and so is this. And so our answer is also going to be a 2 by 2. It's going to be the same size. All right, so let's just go through each one of these one by one. Usually with adding or subtracting, I don't show work. You can use a calculator if you want, but I usually just add them or subtract them. So here we're going to do 4 minus 3. 4 minus 3 is 1. Okay, and then let's do 1 minus 11. That's negative 10. And then we'll do 5 minus 6. So you always want to make sure you're adding or subtracting the numbers that are in the same position. 5 minus 6 is negative 1. And then lastly we have 9 minus 7, and that is 2. So there is your answer matrix, 1, negative 10, negative 1, 2. Okay, here's another subtraction one. You can see these are both 1 by 2s, just like number 7. And so we're just going to subtract, and it's going to form the same size matrix. So first up, 9 minus 13. So 9 minus 13 is negative 4. Secondly, negative 1 minus 2. Now be careful when we got some negatives going around here. Sometimes it can be helpful to use a calculator or to actually write it out. Negative 1 minus 2. If you do that correctly, you should get negative 3. That's our answer. Number 10, another subtraction one. All right, and you can see this is going to be a 2 by 2, just like the originals. So let's go through each of these. 10 minus 1 is 9. 7 minus 8 is negative 1. 5 minus 2 is 3. And lastly, 3 minus 4 is negative 1. Okay, that's our answer. Nothing else to do with that one. Okay, now what's going on here in number 11? We have this number sitting outside the matrix, and then we have the matrix there, which is a 2 by 2. Well, when you have a number sitting outside the matrix, it's called a scalar. This is actually one of the last things we learned about in the last lesson of Chapter 9. And what a scalar does is it scales all the numbers in the matrix either up or down. And so what you're going to do is just distribute that 5 by multiplying it by every single number in there. And that's all you do with this one. And we'll get the same size matrix on the other end. So 5 times negative 2 is negative 10. 5 times 0 is still 0. It's still 0. 5 times 4 is 20. And 5 times 5 is 25. And you see how if you compare the original numbers with the new numbers, each of the new numbers is exactly 5 times as big. So we use a scalar. One way we use a scalar is if we wanted to dilate a shape, make it 5 times bigger. And so these coordinates would be 5 times as large, and they would scale it up. Here's another one. We're just multiplying each one of these by negative 3. You can see this is a 3 by 1 matrix. It has 3 rows, but only 1 column. So just multiply them all by negative 3. Negative 3 times 8 is negative 24. Negative 3 times negative 4 is positive 12. Negative 3 times positive 3 is negative 9. And that's your answer. Scalar multiplication is a lot simpler than matrix multiplication, which we'll be doing soon. And here we are with matrix multiplication, number 13. All right, so you can see there's no plus sign between these matrices, there's no minus sign, and there's not just a single number out front that we call a scalar. So this is an example of matrix multiplication. Even though you don't see a times sign there, it's like there is a times sign between these two matrices. And let's just review the rules of multiplying matrices. Let's say you have a matrix and it is A by B, so A rows and B columns, and you have another one that you're multiplying, and it is C by D. Well, in order to multiply these matrices, in order to even be allowed to do it, the two middle numbers here must be equal. And the outside numbers, in this case A and D, that's going to be the dimensions of the new matrix. So, in number 13, we have a 1 by 3 matrix, and we have a 3 by 1 matrix. So yes, they can be multiplied because they're the same. And look at this. This is interesting. The numbers that are left over, 1 and 1, that's going to be the dimensions of the new matrix, a 1 by 1. So it's kind of an interesting matrix to start reviewing multiplication matrix on. The basic idea when you multiply matrices is that the first matrix you're going to multiply going across the rows, and the second matrix you're going to be multiplying going going down the columns, and it has to be in that order. The first matrix is always across the rows, the second matrix is always down the columns. So since I know this is going to be a 1 by 1, I might make a matrix that's about that size. Sometimes what I like to do is make one that's going to be where I show my work, and then I'll make my final answer one that is more to size. And I know this is just going to be a 1 by 1, so there's only going to be one number in our answer. So, to start off, take the first number in each matrix. So I'll take 11 and negative 2, and you're going to multiply them. 11 times negative 2 is negative 22. And then you're going to move across the row of the first matrix and down the column of the second. So now I'll take a look at negative 3 and 0, and you're going to multiply those. Negative 3 times 0 is 0. And then we'll continue across the row and down the column. 6 and 1. 6 times 1 is 6. So then those numbers, you need to add them. So negative 22 plus 0 plus 6 is negative 16. And that's our answer. That's how we end up with only one number in our answer. This was kind of a weird one to start with. But as we do a few more of these, if you're really reviewing this to remember how to do this, it'll make sense. Just keep following along. All right, number 14. So you got to name off the dimensions. This is a 2 by 2, and this is a 2 by 2. So yes, they can be multiplied, and probably no surprise here, the new matrix is also going to be a 2 by 2. All right, so I'll kind of do the same thing, where I'm going to make one matrix kind of oversized, and that's where I'm going to show my work, and then I'll do another matrix that's more along the size of what it actually needs to be. Okay, so sometimes it can be helpful to split that into the dimensions. This is a 2 by 2, so I know it's going to be 2 rows and 2 columns. And so remember, the first matrix is all about the rows. The second matrix is all about the columns, and they have to be multiplied in this same order. If you flip-flopped these matrices, you would not get the same answer. So leave it in the order it's in. You can't change the order. All right, so first up, we're going to take the first row and the first column. And so we'll do 2 times 10 is 20, and we'll do 6 times 3 is 18. And then we're going to add those numbers together. 20 plus 18 is 38. So that will be the first number in our matrix. The reason why we multiplied those numbers that we did is because this number here is in the first row and first column. So you're going to multiply the first row by the first column. If I move over to this number here, or what will eventually become this number here, I'm still in the first row, but now I'm in the second column. So I'm going to multiply the first row by the second column. So I'll do 2 times negative 4 is negative 8, and then I'll do 6 times negative 7 is negative 42, and we'll add those. Negative 8 and negative 42 makes negative 50. Okay. And really, when you multiply, you can choose to go in whatever order you want as far as which number you figure out first. I usually just start at the upper left and go across and then go to the bottom row, but you could do it in a different order if you wanted. So now here, if I want to know what this number is, I'm in the second row this time, but back to the first column. So we're going to multiply the second row by the first column. So we'll do negative 5 times 10 is negative 50, and 9 times 3 is 27. And so we got to add those, and you get negative 23. Feel free to use a calculator as you do this. That's no problem. But make sure you move across or down each time you do that. All right, lastly, I am in the second row, second column. So we're going to multiply the second row by the second column. So you're going to start by multiplying negative 5 and negative 4, and that makes positive 20. And this is what I mean by you got to keep moving. Don't stay on the negative 5 when you go to the next number. You got to move across to the 9. And don't stay on the negative 4. You got to move down to the negative 7. So 9 times negative 7 is negative 63. So 20 and negative 63, when you add those together, you get negative 43. All right, and there's your answer. It's a 2 by 2. What I've said is, now that you're no longer a beginner at multiplying matrices, you've done it before, you've done it for the last 2 weeks or so, I'll leave it up to you if you want to show this work or not. I find it helpful, and I show it all the time. But if you get one that's kind of simple, or I don't know, you feel confident without doing it, I'm not going to count it wrong if you have the answer correct if you didn't show this. Because when you get really good at dealing with matrices, you can just figure out these numbers as you go, especially if you're using a calculator. So the important thing is that you have these numbers in the right order and in the right place. All right, let's do number 15. Okay, ooh, this one looks bigger. Let's see what we got here. We have a 2 by 3 and a 3 by 3. So yes, these can be multiplied, and the new answer is going to be a 2 by 3. So our new answer is actually going to look a lot like the first one here. So you can do the same thing and set up kind of a matrix where you show your work and another matrix. I'm going to do this one by what I call the grid method, and I've showed this in class before. And it's the exact same work, it's just looking at it visually slightly different. I'm going to draw out the first matrix and put it on the left side where it belongs. You have to put this one first because it comes first. And then I'm going to draw the second matrix, but I'm going to put it, instead of right next to it as you see them originally, I'm going to move it above. So I'm going to put it up here in this space. So 6, 0, and 1. And I kind of like to go wide with this. You'll see why. Negative 2, 9, and 4, and 5, negative 8, and 1. And then what I'm going to do is draw some grid lines. We know the first matrix is all about the rows, so I'm going to draw a line separating this in half going across the rows. The second matrix is all about the columns, so I'm going to kind of split up these according to columns, and you'll see where my new matrix is going to be formed here. And remember, our new matrix is a 2 by 3, 2 rows, 3 columns, and that's exactly what we have. We have 2 rows, 3 columns. And this will be kind of where I show my work. I'll do another one down here that looks a little bit nicer and is not so oversized. Because when you show your final answer, I don't want to see all these grid lines in there. I want it to just look like a normal, regular matrix. What I like about arranging it like this, where you put the second matrix above, is it makes it really, really clear which rows and columns you're multiplying. For instance, when I want to know what number is going to be here, follow the lines and the spaces. I'm going to be multiplying this row by this column. And so we can go ahead and do that right now. We'll be doing negative 7 times 6. That's negative 42. See, I might even zoom in on this to give myself more room because I'm going to need to put a few numbers in there. All right, now I'm zoomed in. So yeah, negative 7 times 6 is negative 42. And then we're going to add that to, what comes next? Well, we got to go across the row. 0, I get down the column, times 0. Oh, that's coincidence. 0 times 0 is 0. And then we have 2 times 1 is 2. So negative 42 plus 0 plus 2 is negative 40. I'll go ahead and put negative 40 in my first spot there. Okay, now let's go across and do this number next. And you can so clearly see you're going to be using negative 7, 0, and 2 again, but now you're going to be multiplying that by negative 2, 9, and 4. So first up, negative 7 times negative 2 is positive 14. 0 times 9 is 0. Watch out for those zeros. They turn everything to 0. And then lastly, 2 times 4 is 8. So plus 8. So 14 plus 0 plus 8 is 22. Okay. And now I'm still in the first row. As you can see, we're still in the first row. but now we're in the third column. So we'll do negative 7 times 5 is negative 35. 0 times negative 8 is 0. And then lastly, we have 2 times 1, which is 2. So negative 35 plus 0 plus 2 is negative 33. Great. On to the second row here. And you can now see we're going to multiply the second row by the first column again. So 4 times 6 is 24. Negative 11 times 0 is 0. 1 times 1 is 1. So 24 plus 0 plus 1 is 25. Okay, here we're going to multiply this second row by the second column. So 4 times negative 2 is negative 8. Negative 11 times 9 is negative 99. And 1 times 4 is 4. So again, feel free to use a calculator with this. The way I think about this one is negative 8 and negative 99, those add together to make negative 107, and then 4 is going to add 4 to it, so negative 103. Alright, and the last one. This goes a lot faster when you're not explaining every step as you do it, right? When you do these, it's not going to take 4 minutes to do one problem here. Okay, so here we are. We're going to multiply the second row by the third column. You can so clearly see how it's lined up like that. So 4 times 5 is 20. Negative 11 times negative 8 is positive 88. And 1 times 1 is 1. So, all right. 20 plus 88 is 108. And then plus 1 makes 109. And there you have your answer. Again, make sure you write your final answer just as a regular looking matrix. You can draw the grid lines and everything as you're working, but in your final answer, it should just look like a regular, straightforward matrix. So that's your answer. All right, number 16. Here we have another matrix multiplication problem. This is a 2 by 3, and this one is a 3 by 1. So yes, they can be multiplied because these middle numbers here match. And the answer is going to be a 2 by 1, the numbers that are remaining on the outsides there. All right, so isn't that interesting that we can multiply two matrices and the answer might not look like either of the originals? I'm going to go ahead and use the grid method with this one. You feel free to do it however you want and show however much or little work you want. But if you're watching this video, it's probably because you have some questions about the review and you want to make sure you do a really good job with it. And so if you're kind of unsure about how to do these, I would definitely use this grid method here. So we put the second one above it, and then we can kind of draw these grid lines here. Well, it's really only going to be one grid line. And because our final answer, a 2 by 1, is just going to have 2 rows, 1 column. So you're going to have a number up here and a number down here. And I'll go ahead and put my final answer version over here. So it's going to be a little bit taller. Okay, so again, when you line up according to this grid method, it's so clear that you're going to be multiplying 0, 3, and 5 by negative 4, 2, and 7 at first. So 0 times 4 is 0, 3 times 2 is 6, and 5 times 7 is 35. So 0 plus 6 plus 35 is 41. Okay, great, we're half done. Then on the bottom, we're going to be multiplying 1, 0, and 9 by negative 4, 2, and 7 again. So 1 times negative 4 is negative 4. 0 times 2 is 0, and 9 times 7 is 63. So negative 4 plus 0 plus 63 is 59. And there's our answer. Okay, the next type of transformation that we learned about was reflections, where you flip a figure across a line, and it will be the same size and shape, but it will be in a different place, and it will be flipped. So it'll be a different orientation. And part of what we reviewed when we learned this was how to graph lines. So sometimes they don't give you a line equation, like in number 17, it just says reflect it in the x-axis. So You just take the x-axis, I'm going to highlight it here for emphasis, and we're going to flip it. It's as if you could fold the image of this triangle across the paper onto here. And if one of the easiest ways we did this is we just counted the distance from each of these points to the line of reflection, and we counted that same number across to the other side. The thing that you might not think about is that you always want to count perpendicularly. So since this is a horizontal line, we want to count going up and down. So make sure that you do that. So for instance, B, which is at 4, 5 right now, notice they're going by 2's, B is 1/2, 1, 2, so 2.5 grid lines from the line, so you count 1, 2.5 grid lines across to the other side, and here is going to be the new B. And yeah, A, as you can see, is 1 grid line, and so we're going to count 1 grid line down, and here is going to be the new A prime. C is 1/2, 1, so 1.5 grid lines, so you're going to count 1.5 grid lines down going across the line. And there is C prime, and we'll make dotted or dashed lines to connect these. And so you should notice it's the exact size and shape, but it just has been flipped. As I tell my students here, you can literally fold your paper over this line, and if you look closely, you should see these triangles match up. Now, that's all you have to do for this problem. You're done. However, if you're checking your answers in the answer key gives the coordinates for where the new figure is, for where the image is. So it's probably a good practice to name the coordinates as we go here. So A, the new A prime, is over 2, down 2, so 2, -2. Notice that this grid line is set up to go by 2's. B is over 4 and down 5. So 4, -5. And C is over 6 and down 3. So 6, -3. Or another way you could count those is if you just count the grid lines, like C is over 3. So that would be 6 actually, and it's down 1.5, so if you double that, that's 3. Alright, let's look at 18. This time we're going to reflect this in the y-axis. So I'm just going to highlight the y-axis for emphasis here, and we're going to flip it over that line. So we'll just count, but this time, since it's a vertical line, we're going to count horizontally. Notice we're always counting perpendicular to the line of reflection. So I'll just start with the ones that are closer here. You can see G is just half a grid unit away, so we're going to count half a grid unit there, and there is G prime. D is 1 grid unit away, and so it's going to be 1 grid unit away from the other side. E, you can see, is 2 grid units away, so if you count 1, 2, and then just keep going, 1, 2, and there is the new E prime. And F is 2.5 grid units away. If here's the line, 1, 2.5, so you got to count 2.5, and there is the new F prime. Make sure you make dotted or dashed lines connecting these. And again, they're going by 2's here, and so when you name the coordinates, just be careful that you name them correctly. For instance, D is back 1/2, up 1/2 grid unit, so that's really -1, +1. -1, 1. E is back 2 grid units and up 1, so that's going to be -4, +1. G is -1 going to the left and down a whole grid unit, so that's down -2. So -1, -2. And F, so from the origin we're going back 1, 2.5 grid units, so -5, and down a whole grid unit, so that's -2. -5 and -2. Okay, on to number 19. Okay, here we are still reflecting. We have the same directions as above, but we're reflecting in the line y equals x. Some people get confused when they see a line like y equals x. Well, remember y equals mx plus b. You should, because you learned it in algebra. You really learned it in algebra. And we reviewed it in geometry also. You were tested on this earlier in the year. So got to make sure you know how to graph any line we give you. So y equals x is just so simple of a line that it might be confusing at first. Well, the slope is the number with the x. That's 1, as in 1 over 1. And the y-intercept, you don't see it because it's 0. So this means we're going to start this line at the origin at 0 and go up 1 over 1. Up 1 over 1, up 1 over 1. And so the line of reflection is this line right here. And again, as I said before, when you're reflecting, you're really flipping this triangle over the line. You could literally fold your paper diagonally across this line and you get an idea of what to look for. If you are wanting to just count this, remember, like the ones above, you need to count it perpendicularly. So perpendicular would be like counting it across a diagonal like this. That's what's going to form a perpendicular line to the original. So, for instance, this point right here, I, it looks like, is half a diagonal unit away going perpendicular, so we need to count half a unit away there. So the new I prime, is going to be right there. If you want to, you can fill in the coordinates as we go. That's 2, 1. Alright. J, if we count diagonally going perpendicular, is 1.5 diagonal units away. So go 1.5 the other way right here, and we have our new J, J prime, and that would be at 1, negative 2. And then H, if we follow the diagonal units, kind of going that same way, is 3 diagonal units away. So we got to go 3 diagonal units down here, and this is where H prime is, and you can see that's 3, negative 3. And we'll connect the dots with dotted or dashed lines. And it's the same size shape, same angle, same side lengths, but it has been reflected. So it's flipped and it's not in the same position it was. Number 20. Okay, this time we are flipping or reflecting this in the line y equals negative 3. Now we reviewed this. Anytime you have a line equation where it's just y equals a number and there's no x, you have to know that that is a horizontal line. We've talked about why that is true and everything, but at this point we're reviewing for the test, you just have to know that. If it's just x equals a number and there's no y in it at all, that is the equation for a vertical line. Alright, so in this case, y equals negative 3. This is a horizontal line, and it's at the level of negative 3. So that's down here. Okay, so since this is a horizontal line, we're going to want to count perpendicular to it. We're going to want to count vertically how many grid lines away is each point. So, like R, let's start with R. R is 1 grid unit away. And so we're going to flip R over the line, and it will end up down here. So here is the new R, R prime, and that is at, let's see here, 1, negative 4. Okay, how about S? S is way up here. So let's see here, 1, 2, 3, 4. So then we got to count 4 below the line. 1, 2, 3, 4. And so there's S prime. And what set of coordinates is that? Well, from the origin, we're going over 1, 2, 3, 4, and down 1, 2, 3, 4, 5, 6, 7. So 4, 7 is where S prime is. Okay, and then lastly, T, look at this. T is actually right on the line. And so that means T and T prime are at the exact same place. Nothing wrong with that, just means it was kind of pivoted or tied on that same point. So we'll make our dotted or dashed lines here. And you can clearly see how it has been reflected or flipped over that line. If you folded your paper, you would see it match up. Feel free to do that while taking the test. That's totally fine. Okay, the next type of transformation that we studied was rotations. And here it says in the directions, rotate the figure the given number of degrees counterclockwise about the origin. And unless you're told otherwise, we pretty much always rotate counterclockwise. That's just the convention. So we learned a number of ways how to do this. And rotating about the origin is a little bit easier than picking another point to rotate around. So if you're rotating about the origin, like I've said in class, what I would do is I would literally turn your paper 90 degrees. So that would look something like this. See if I can get that a little more lined up. Okay, and when you turn it 90 degrees, make sure you turn it counterclockwise, like this, in this direction. And since we're rotating about the origin, this is still the origin, all right? And I know this looks kind of weird and everything, but what you want to do is take each of these points, A, B, C, D, and figure out where it is now. So according to this, A is now at -1, -3. So maybe write that down or remember it, or, -1, -3, let's rotate our papers back and plot -1, -3. So -1, -3 is right here, and that is the new A prime. It's at -1, -3. Okay, now let's rotate again. So, let's see if I can do this. Okay, so how about B? Where is B at? Now, here's the origin. We're still going off the origin. B is at -3, -3. So -3, -3. So now let's turn our papers back. And go to -3, -3. And this is where B is going to end up. You might be able to start to see it, how this rectangle has rotated 1/4 turn counterclockwise to there. All right, we'll do the same thing with C and D. So when I rotate 90 degrees, you can see D is at -1, +1. So -1, +1 is right here. And let's rotate it one more time to get C. Alright, right now when we rotate it, C is at -3, +1. So -3, +1, let's rotate back and write it in. So -3, +1, that's right there. Oh, by coincidence, C is now occupying the same space, C prime is, that A once did. Alright, we'll connect these with dotted or dashed lines. And it should look like it rotated 90 degrees. And so that's our answer. In my opinion, that's the easiest way to do a rotation if it's about the origin. All right, number 22. 180 degree rotation, counterclockwise. Another way that I showed how to do rotation is to make what I call an L shape. To make an L shape from the origin. So here's the origin. So let's say I want to do D. I want to rotate D. One way that I can get from D to the origin is to make an L shape that looks like this. And so from the origin, I'm kind of counting 1 and 2. I'm going over 1 and up 2. But if I were to rotate that 90 degrees, so like this, instead of going 1 to the left, it would now be going 1 down. Instead of going 1 up, it would be 1 over. So it would have moved there. Now that would be a 90-degree turn. If I were rotating D 90 degrees, it would end up right there. But I got to go 1 more. So I'll go 1 over and 2 down. And this is where D is going to end up. Now, I got all those L lines in there, so I need to go back and erase those. You really don't want those as part of your answer. Your answer is crowded enough without those in there. So that's one way how to do that. If you're rotating about the origin, though, I really think it's just a lot easier to rotate your paper. So I think that's what I'll do. All right, I've rotated my paper. Now remember, we've already done point D, so we don't need to do that one. If you want to save a little bit of time here, what you can do is somewhere on your paper write down the coordinates for all of the points as they are now, and that way you don't have to go back and forth rotating your paper in between every point. But you can do that also. It's not hard to do. So I'm going to get out a pen and a piece of paper here, and I'm going to go ahead and write down what each of these are. So A, the new A prime, is going to be at 2, 0. And B is going to be at 3, negative 2. B prime will be at 3, negative 2. And C prime will be at 2, negative 4. 2, negative 4. All right, I'm going to rotate my paper back 180 degrees. Okay, so you remember the names of those points that we wrote down? A prime was at 2, 0. So 2, 0, A prime. B prime was at 3, negative 2. And C prime was at 2, negative 4. So if you're rotating about the origin, that's probably going to be the easiest way to do it if you can visualize it. Now, we did talk about some other ways of doing a rotation. When you look at number 23, sure, we can just rotate this. And we're rotating 270 degrees, so that's 90, that's 180, and this is what 270 would look like. And so, I think it's probably easiest just to count where these coordinates are according to the origin here. But if that confuses you, or if you just want to know how to do this a different way, we can also use a matrix to do this. So we know it's going to end up somewhere down here. Let me rotate us back to where we need to go. And so we learned some matrix rotations. You don't have to memorize these matrices, you just have to know how to use them. They will be given to you on the test. So let's see here. Let's look those up. So the matrix for rotating 270 degrees looks like this. It's a 2 by 2 matrix, and it's 0, 1, negative 1, 0. And if we multiply this special matrix by our figure, and we make our figure into a matrix, the answer, the product matrix, will come out with the correct rotation. So I'm going to go ahead and multiply this the grid method way. One very important detail about doing this is that when you multiply them, the multiplier matrix, the special one that we had to look up, that one has to go first. All right, and the figure, the quadrilateral in this case, would have to go second. I'll go ahead and line up A, B, C, D up here. So A, what are the coordinates of A? Well, it's at 0, 2. B, give myself a little more room here. B is at 1, 4. C is at 6, 4. And D is at 5, 2. All right, so we're going to multiply these. You can either do this kind of the normal, regular, straight across, left to right way, or you can do it the grid way, how I'm going to do this. I'm going to zoom in here. So, multiplying this using the grid method, we'll have a grid line going across there, one here, and one here. And so you can see that this makes a 2 by 4 matrix. It has 2 rows and 4 columns. And again, I'll kind of get a more nice looking final matrix lined up here. I'm going to go ahead and label it because the way it's going to come out is in the same order except with our new coordinates, A prime, B prime, C prime, and D prime in that order. All right, again, what I like about the grid method is that when you go to multiply, like this first spot here, you know exactly what you're multiplying. So we'll do 0 times 0, which is 0, and also 1 times 2, which is 2. So add those. 0 plus 2 is 2. All right, on to the second spot. 0 times 1 is 0. 1 times 4 is 4. So 0 plus 4 is 4. All right, on to the third spot. 0 times 6. Ooh, I'm sensing a pattern here. 0 times 6 is 0. 1 times 4 is 4. So we get 4. All right, in this spot, 0 times 5 is once again 0, and 1 times 2 is 2. So 0 plus 2 is 2. All right, bottom row. See, this goes pretty quick. Bottom row, negative 1 times 0 is 0. 0 times 2 is 0. So 0 plus 0, 0. All right, in this position right here, negative 1 times 1 is negative 1. 0 times 4 is 0, so we get negative 1. Right here, negative 1 times 6 is negative 6, and 0 times 4 is 0, so negative 6 is what you get when you add them. And lastly, in this spot here, negative 1 times 5 is negative 5, and 0 times 2 is 0, so negative 5. All right, now you have to graph these. Okay, so it's not enough just to get the answer with the matrix. We want to see where does this end up. So each of these is an ordered pair, right? A prime is at 2, 0. Great, there is A prime. B prime is at negative 4, negative 1. I'm sorry, positive 4, negative 1. So there is B prime. C prime is at 4, negative 6. Ooh, this goes off the graph. That's okay. We can just estimate where it is. So let's see here. 1, 2, 3, 4, and down. Let's see here. That's 2. That's about 4. I'd say that is about 6. About right here. And you know what? If you don't get it exactly on, first of all, how would I know unless I took out a ruler and measured, and I'm not going to do that. But second of all, you have the coordinates right there. So that's the thing that tells me, did you know what to do? I want it to be in the right area, but, you know, just be close. And the last one, D, is at 2, negative 5. We'll have to estimate where that is. 2, and then down 5. I'd say that's probably about right here. All right, and then we'll make some dotted or dashed lines to connect these. And you see how it's been rotated. It's still the same quadrilateral shape, same angles, same side lengths, but it has been rotated 270 degrees, so almost a full 360 rotation, but not quite, just a quarter turn short of that. Okay, last one, number 24, and I will just go ahead and do this one using the rotating my paper trick. So you can see where A, B, and C are originally at. I'm going to rotate 90 degrees, so that's just a quarter turn counterclockwise. Alright, so let's rotate this. So 90 degrees is just a 1/4 turn. Gotta get it lined up just right. That's pretty close. Okay, so I'm going to do what I did the last time. I'm going to take A, B, and C and get out a separate sheet of paper, or write, you know, in the margin of my paper somewhere, maybe over here. And I'm going to write down where they are now, and then I'm going to flip it back and actually graph it. So A is at negative 3, negative 3. So A prime will be at negative 3, negative 3. B prime, counting from the origin, I'm going back 1, 2, 3, 4, 5, 6, and up 1, 2, 3, 4, 5. So negative 6 positive 5 is where B prime is at. And C is at negative 2, positive 2. So C prime, negative 2, positive 2. Now let's rotate the paper back. Okay, and let's try to get this right. That's pretty close. Oh man. Alright, this is pretty close. I'm going with this. Alright, so do you have those numbers written down? A prime was at negative 3, negative 3. Ooh, looks like we're going off of the grid again. That's alright, we'll just estimate. Negative 3, negative 3. I'd say that's about right here. So that is where the new A prime is going to be, and I'll go ahead and label my coordinates. B prime is at negative 6, positive 5. So negative 6 and positive 1, 2, 3, 4, 5. Ooh, I'm going to run into my other work here. That's okay. So about right here, if you can see where I'm putting that blue mark there, that's where B prime is going to end up. I'll label it negative 6, 5. And C prime is going to end up at negative 2, positive 2. That one's probably the easiest to graph. Negative 2, positive 2. So again, make sure you have them labeled clearly. Let's draw some dotted or dashed lines in here. Alright, and it looks like it was just rotated 90 degrees. Alright, we also learned how to put some of these together. We call this a composition of transformations. So I'm going to start off by just graphing A, B, and C, the triangles, in these first 4 examples. So give me a minute and I'll be right back. You should do the same. Okay, you can see I have them all drawn in and labeled. Looks like B goes off the graph a little bit, but like we said before, that's fine. And so we're going to do the composition of transformations, and we have to go in order. So it looks like in number 25, first we're going to do a translation. And so if you remember how to do this from a couple pages ago, looks like in this case we'll be going left 4 and down 3. So we're going to go ahead and do that. Left 4, I'll just go in order from A, B, C, and down 3. A prime will end up right here. For B, B prime will end up right here. Sometimes the shapes kind of overlap a little bit. And C prime will end up right here. Now, we have another transformation to do. All right. Now we're going to reflect this in the x-axis. So let's see here. This is the x-axis. And the important thing to realize, some people make this mistake, is that we are going to build on our most recent triangle. We're not going back to the original. At this point, we don't care about the original. We're done with it. But we're going to go off A prime, B prime, C prime, and we're going to get A double prime, C double prime, and B double prime. So we'll just count. Right now, C is 1 unit away. So just counting 1 unit up, and there is C double prime. You can see it is at coordinates 1, 1. Again, I'm going to label where my final answer is, just so that you can look it up in the answer key, because that's how the answer key is listed. A prime is 1 unit away, so it's going to go 1 unit this way. So A double prime is at negative 2, negative 1. And B prime is 3 units away, so count 3 units down. And there's B double prime at 3, negative 3. And we'll want to connect those dots. So both the A prime, B prime, C prime, the first change, and A double prime, B double prime, C double prime, those both get dotted lines. If you want to bring in different colored pens or pencils for the test, feel free to do that. You don't have to, certainly, but you can. Alright, number 26. Looks like we are going to move this 2 to the left for the first thing, and that's all we're going to do for the first thing. The y, there's no number next to the y, so it's just 2 to the left. So A prime will end up here. B prime will be there, and C prime will be here. We're just sliding it over too. So draw some dotted or dashed lines, connect that. Great. Now we're going to rotate this 90 degrees about the origin. Okay, so now we need to look at our A prime, B prime, C prime, not at the original, but at our new triangle here. So A is at -4, 0. I'm just going to go ahead and write that down on a separate sheet of paper here. You should do the same. -4, 0. B, starting from the origin, is at -1, 2, 3, 4, 5, 6, and +1, 2, 3, 4, 5. So -6, 5. And C is at -2, +3. -2, 3. All right, now let's rotate this back and actually graph those here. Let's see. How can I get this back? Okay, so I'm going to plot those points now. A was at -4, 0. So this is going to be A double prime. And again, I'm going to write down the coordinates because this is how you're going to check your answer with the answer key to make sure you're getting it right. B was at -6, 5. So there is B double prime at -6, 5. And C is going to be at -2, 3. -2, 3. There's C double prime. And now we'll make our dotted or dashed lines. And you should be able to follow what happened here just visually. It should make sense visually. First, our original shape just shifted over 2 units, and then it rotated 90 degrees. So there we are. We're finished. Number 27. Okay, it looks like this one is doing 2 translations. The first translation is just going to shift 5 to the left, and that's it. So let's go ahead and do that. A shifted 5 to the left is going to end up here. So there's A prime. B is going to be right here. And C prime will be right here on the y-axis. And go ahead and make the dotted or dashed lines. And then for our second transformation, looks like we're going to go over to the right one, and down 2. So let's do that in order, A, B, C. Over to the right one and down 2. This is where A double prime is going to be. I'm going to write down the coordinates. That's -2, 2. B to the right one and down 2 is going to end up right there. So that is 3, 4. And C is going to end up right here, and that is 1, 0. It probably looks a little nicer when we make our dots or dashes. Now really, this could have been accomplished in one move. You might be able to see that with this original triangle could have just shifted right to where it ends up, but the directions said to do 2 translations, so we did. Okay, our last type of transformation that we're just introducing now, number 28, is a dilation. And it says dilation k equals 2. That means that's the scale factor of the dilation. It means that the new one is going to be twice as big. And the way that we studied dilations is with a scalar multiplication. So I'm going to go ahead and take our ABC coordinates and make them into a matrix. Let me get to a spot where I have a little more room. So A, the coordinates of A right now are 2, 4. B, and actually these are just the original points, so I'm just going to go up here. B is at 7, 6. And C is at 5, 2. And to dilate this, all you're going to do is multiply by the scale factor as a scalar. So you're going to take that 2 and just put it out front. So just like we did earlier in the packet with scalar multiplication, you're just going to multiply all of those by 2. And the answer will come out in order A prime, B prime, C prime. So for A, 2 times 2 is 4, 4 times 2 is 8. So our new coordinate, A prime, is going to be at 4, 8. That is right here. All right, B, when we multiply both of those by 2, we're going to get 14, 12. I think that might go off the graph. That might go off the graph a little bit. Let's see here. 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we need to go 4 more off. So I'll estimate that's about right there. And then up 12. So that's going to be up there. That's going to be off the graph as well. And so there is B prime. When we do C, we'll multiply those by 2. We'll get 10, 10, and 4. And that one will stay on. So 10 and 4. C prime is right there. Okay, go ahead and draw those dots or dashes in. And we're not even done with this problem yet because we have to do one more thing. We have to flip this across the y-axis. Alright, so here's the y-axis. I'll draw it in as best I can for emphasis. And we're going to flip it across that y-axis. So everything's just going to flip from the right side of our graph over to the left side. Let's start with A. Right now you can see A is 4 units from the axis, so we count 4 units the other way. Let me zoom in here, 4 units. And here is A double prime. So what would the coordinates for that be? From the origin we're going -4 and up 8, so -4, 8. Okay, let's do C next. I'll save the harder one for last. C, and let's see here, C is 10 units away. So we have to count 10 units the other way. So that's going to end up right here. That's C double prime. So that would be at -10. So C is at -10, 4. Alright, now for B. You can see B is way up here off the graph. And what we may want to do is rely on the coordinates where we know B is supposed to be. B prime is at 14, 12. And so to really understand this reflection, what we would notice is that the x-coordinate of 14, the fact that it's 14 to the right of the y-axis right now, when we flip that, it's going to be 14 to the left. The height of B prime is 12, and you notice it's going to stay at that exact same height. So we'll just kind of estimate where that point is. 14 to the left and 12 up, I would say, is about right here. And we'll mark that B double prime, and we can connect the dots, making sure to use dotted or dashed lines. But we should come up with a set of coordinates for B double prime. Again, if you look at our B prime was positive 14 to the right. This is going to be negative 14 to the left. So negative 14, but it's at its same height. So it's going to be negative 14, 12. And there it is. Okay, the next lesson, we kind of got to take a break from all of that coordinate graph work, and we're talking about lines of symmetry and rotational symmetry. We'll start off with line symmetry. Line symmetry is just, can you draw a line through the figure and have it reflect onto itself? And so you see, with the line that I drew there, You can. The left and right side can fold over and map each other exactly on. We can draw another one here and another one here. So this one has 3 lines of symmetry. Number 30, you can see, is not a equilateral triangle. It will still have 1 line of symmetry right there. But that's it, at least as far as we know. Number 31, oh, isn't that nice? A little heart. We can draw a line of symmetry going right down the middle there, so there would only be 1. You notice it wouldn't work to try to split it in half like that or at a diagonal. Those just wouldn't work. So just 1 line of symmetry. Number 32, we have a couple here. You could split this right down the middle. That's one. You could also split it this way. So a vertical line and a horizontal line are 2 of our most common ways that we can use symmetry. Let's take a look at this one, number 33. I might zoom in on it a little bit. So yeah, we could have a straight vertical line. Let's see if I can draw that better. A vertical line, that will split it in half. And a horizontal line will split it in half also. Will a diagonal line work right here? Yeah, it will. And again, if you literally want to fold your paper over, whether you're doing this on a review or an assignment, a quiz, or a test, feel free to do that. I do not mind the crease lines. And so we could also do another one right there. So this will have 4 lines of symmetry. And number 34, I think we could do 1 line of symmetry here. And if we're taking into account all of the geometric parts of this, the eyes and the smile, it's only going to work one way. If it was just a circle, how many lines of symmetry does a circle have? Well, it could have one here, 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 here. It would actually be an infinite number of lines of symmetry. But the way that number 34 is drawn is just 1. All right, on the last page here, you can see the matrices that I was talking about. And this key, so to speak, will be given to you as you take the test. So you don't have to memorize these, but you got to know how to use them. When we give you a graph and tell you to reflect it or to rotate it, it's kind of up to you exactly the method that you want to use. But we also want to know that you can use a matrix. Maybe using a matrix isn't always the most efficient way or the easiest way or the way that you would prefer. But we have to know that you can do this. If you are ever working with computer graphics and you need to program certain changes to them, those changes will be programmed using a matrix. That's one of the reasons why. And a lot of you are going to do stuff with computers. But we also use matrices in Algebra 2 and in pre-calculus and calculus and so on. So, all right, number 35. We have a matrix here that represents a triangle. I know it's a triangle because there are 3 columns in this. And each one of those represents an ordered pair, a point. And so we want to reflect this across the x-axis. So x-axis, we're going to take this matrix right here, and we're going to write it first. And that's kind of the trick to doing this that you have to remember, that has to be done this way, is that you have to put the special multiplier matrix first. And then you put your polygon matrix. I'm going to zoom in and notice the way that I have written this down. I'm going to be using the grid method. And so I can make my grid lines in there, and you can see this is going to end up as a 2 by 3. It started off as a 2 by 3, and so it would make sense that it's going to come out as a triangle as a 2 by 3 also. So I'll get ready my final answer as well. All right, let's go ahead and multiply these. So in this spot, we're going to be multiplying 1 and 0 times 4 and 1. So 1 times 4 is 4. 0 times 1 is 0. So 4 plus 0 is 4. Let's do the next one here. 1 times 1 is 1. 0 times 3 is 0. So 1 plus 0 is 1. In the last spot in this row, 1 times 7 is 7. 0 times 5 is 0, so 7 plus 0 is 7. You notice we actually didn't change our first row. 4, 1, 7, and we still have 4, 1, 7. Let's do the bottom row now. So down here, we're going to multiply 0 and negative 1 by each of these columns. So 0 times 4 is 0. Negative 1 times 1 is negative 1. You add those, and you get negative 1. So this is not the exact same, but it's the opposite. Let's see what happens next. 0 times 1 is 0. Negative 1 times 3 is negative 3. Add those together and you get negative 3. Oh, you might notice a pattern here. In the last spot, 0 times 7 is 0. Negative 1 times 5 is negative 5. We get negative 5. So it looks like the first row didn't change at all, and the second row just went opposite. And so actually that's what happens when you reflect across the x-axis. All of the x-coordinates stay the same, and all of the y-coordinates flip. And so there's our answer. It said that we could answer this as a matrix, and if we wanted to graph this, we could, but in this case, that's all we have to do. All right, next, looks like we have another triangle, and we're going to do a 180-degree rotation. So, take the 180 rotation matrix, and I'll do this again using the kind of box grid method, -1, 0, 0, -1. Get some grid lines matched up here. Again, it's up to you how much work you want to show when you multiply these matrices. I usually show some work. If you realize you don't really want to, or it's just easier to do it without, that's fine, I guess. Okay, let's go ahead and do this. Going across the first row like I usually do. -1 times 5 is -5. And 0 times 0 is 0. So -5 plus 0 is -5. Then we have -1 times -3 is +3. And 0 times 8 is 0. So 3 plus 0 is 0. Oh, you might notice what's happening. The first row is just being opposited, I guess you might say. So I would bet that the next number would be -4. You should probably check it just to make sure. But we have -1 times 4 is -4. And 0 times -1 is 0. Okay, in the bottom row here we have 0 times 5 is 0, and -1 times 0 is 0. So 0 plus 0 is 0. Then, here we have 0 times -3, that's 0. -1 times 8 is -8. So 0 plus -8 is -8. And lastly, 0 times 4 is 0. -1 times -1 is +1. 0 plus 1 is 1. And there is our answer. So, when you get the hang of it, it goes pretty quickly. Okay, looks like we got a couple more to do. Next, we're going to grab the 270-degree rotation matrix. Make sure you put it first. So 270 is 0, 1, -1, 0. And maybe I'll do one without using the grid notation. So I'll just make the matrix that's given to us. And you can probably already tell that this is going to end up as a 2 by 3 because it's still a triangle. It's still 3 sets of ordered pairs. One way that you can kind of have the same effect as the grid method without actually showing it is to do some circling. So like here, I know I'm in the first row in the first column, so I can multiply the first row by the first column. So 0 times 7 is 0. 1 times -2 is -2. Add those together and you get -2. The disadvantage with this is that you have to go back and erase those circles every time that you do that. But I'll do that now. It's no big deal. So now moving across, I'm still in the first row, but now I'm going to be in the second column. So first row times the second column. 0 times 5 is 0. 1 times 4 is 4. Add those together, and you get 4. So now, let me erase here. Okay, so now to do this last one in the first row here, we're going to multiply 0 and 1 by 0 and 8. So 0 times 0 is 0. 1 times 8 is 8. Add those together, and you get 8. Okay. Alright, so now I'm kind of out of the first row, and I'm going to be multiplying everything with the second row. So I'm going to have negative 1 and 0, and I'm going to be multiplying those by each of these columns. So let's start off with negative 1, 0 times 7, negative 2. So negative 1 times 7 is negative 7, and 0 times negative 2 is 0, so that's just going to be negative 7. Now I'll do the next one. Negative 1 times 5 is negative 5, and 0 times 4 is 0. So it's just going to be negative 5. Negative 1 times 0 is 0, and 0 times 8 is 0, so add those together and you get 0. So there is your answer. It's kind of harder to explain when you don't show as much work, but you could do that if you wanted. Okay, number 38. We need to reflect this across the y-axis. You can see this one's no longer a triangle. It's some kind of quadrilateral because there are 4 columns in it. So let's grab the reflect across the y-axis matrix. Looks like it's negative 1, 0, 0, 1. Negative 1, 0, 0, 1. Okay, I'll go back to the grid method for this. I think it's just a lot easier to explain, and if you're watching this, it's probably because you want help explaining these things. So, go ahead and draw in my grid lines. This is going to end up a quadrilateral because it started off a quadrilateral, so it would make sense that it is a 2 by 4 matrix. All right, and then I'll make my final answer one down here, so it'll be a little nicer without all those grid lines in there. Okay, so here we'll start off. Negative 1 times negative 1 is negative 1, and 0 times 5 is 0. So add those together and you get negative 1. Next, negative 1 times 6 is negative 6. 0 times 0 is 0, so negative 6 is what we get. Next, negative 1 times 3 is negative 3. 0 times negative 7 is 0, so add those and you get negative 3. And in the first row, fourth column, negative 1 times negative 4 is positive 4. 0 times 2 is 0. Add those, and you get 4. All right, down to the second row now. We're going to be doing 0 and 1 times all of these. 0 times 1 is 0. 1 times 5 is 5. Add those together, you get 5. 0 times 6 is 0. 1 times 0 is 0. So 0 plus 0 is 0. 0 times 3 is 0. 1 times negative 7 is negative 7. So add those and you get negative 7. And lastly, 0 times negative 4 is 0. 1 times 2 is 2. So 0 plus 2 is 2. So here is our answer. That would mean that this quadrilateral is reflected across the y-axis. We usually would just graph that and count it, but there'd be another way to do it, like we just showed. All right, last one, 90-degree rotation. Let's go ahead and grab the 90-degree rotation matrix. Looks like it's 0, negative 1, 1, 0. 0, negative 1, 1, 0. All right, I'll use the grid way once again. And this is a quadrilateral, so it's going to stay a quadrilateral in the end. I'll make our final answer down here. All right, so starting at the beginning, 0 times 0 is 0. Negative 1 times 9 is negative 9. Add those together, and you get negative 9. 0 times 5 is 0. Negative 1 times 2 is negative 2. Add those together, and you get negative 2. 0 times 1 is 0. So you might notice we're getting a 0 for all of these. And then negative 1 times negative 7 is positive 7. Add those together, and you get 7. And lastly, in the first row, 0 times negative 5 is 0. Negative 1 times negative 3 is positive 3. Add those, and you get positive 3. All right, now for the second row. 1 times 0 is 0. 0 times 9 is 0. Add those together, and you get 0. 1 times 5 is 5. 0 times 2 is 0. So add those together, and you get 5. 1 times 1 is 1. 0 times negative 7 is 0. Add those together, and you get 1. And the last one, 1 times negative 5 is negative 5. 0 times negative 3 is 0. Add those together, and we get negative 5. So this would be a 90-degree rotation. We could graph these coordinates if we wanted. In this case, we just want to make sure you know how to do this using a matrix. There you go. Good luck in your studying.